Now this is a combined science 2020 question number 9. So in this question here, you're given that the X and Y component, they are connected in series, and X is basically a fixed resistor of 500 ohms, where Y, this is not a fixed resistor, but rather is actually a thermistor, which you do not learn in combined science. Is in pure physics, but nonetheless it can still come out as long as they give you the information that's required. So you're given this graph here, and that is the behavior of Y, okay, the thermistor. So as you know, if you look at here, as the temperature of Y increases, the resistance will decrease from the curve here. So this is like a temperature sensor, and it changes, the resistance changes with temperature. Alright, so the first thing that they ask you is determine the temperature at which the potential difference X is equal to the potential difference across Y. Now, using your basic, when the Vx is equals to Vy, okay, that means to say both has to be 4.5 volt, 4.5 volt, okay? So because the EMF is 9 volt, so back to here, the only case where you can both have the same potential difference is when they have the same resistance. That means to say this will be 500 ohms also. So from the figure 9.2 here, you know it's 500. So once again, you definitely have to indicate on the graph itself to show the marker how you get the answer. So from here, okay, don't be careless, it's not 12, it's actually 14. Every smallest division is a unit, 2 units. All right, that's how you solve the first part. Next, they give you a condition already where the temperature is 60 degrees, okay, which is over here, and they ask you to find the resistance of Y. So very simple, likewise, you draw the dotted line. So the determine the resistance, so it's just a 1 mark question. The resistance will be 100 ohms. All right, so very straightforward, just purely reading from the graph itself. And so what's the current flowing through Y? So in order to find the current, I need to find the total effective resistance. So Re equals to your Rx plus Ry. So you have 500 plus 100, that will be total 600 ohms. And the current flowing through the main circuit, which is the same because current is the same everywhere and is affected by the total resistance of the whole circuit, which is 600 ohms. So I equals to V over R, and I'm using the EMF 9 volt, and I will be using the total resistance, and that will be 0.015 ampere flowing through. All right, 0.015 ampere. Now, of course, one common mistake by student will be just purely taking the EMF because that's the only V they have, and they divide by the resistance of Y, since the question says what's the current through Y, and they'll put 100. So this is wrong. Remember, if you use EMF and you want to find the current, the main current, and this current is affected not just by the Y itself, but its total effective resistance, which is 600 ohms. So take note of this. This is a common mistake by student. Okay, then for part 3, they ask you to find the potential difference across Y. So that's very simple. You have the current flowing through Y and the resistance of Y. So 0.015 times the resistance 100, so there will be 1.5 volt, which is very straightforward, your simple DC circuit calculation. Now the thing that I want to highlight for this question is the last part here, which is for the explanation. So they ask you to describe what will happen and explain how the potential difference across the X, okay, take note of that, changes as the temperature of component Y increases. So what you want is actually to find the potential difference across your X. Is like you put a voltmeter across here. What will happen as this component as the temperature increases? Now there's actually a shortcut. So first of all, from here for Y, as temperature increases, you know that the resistance of your Y will decrease because it's given in this graph. It's an inverse kind of relationship. So, and if it's shortcut, remember I told you when X and Y, they are connected in series. When the smaller the resistance, the bigger the potential difference. So straight away, you know your Vy will actually be decreasing, because the fact that the resistance of Y decreases, your potential difference will decrease. But you cannot just state that for the explanation, because you won't get any credit. So what should you do? Basically for this, there's a lot of missing links so it doesn't make your explanation complete. So we will actually just start from what is given in the question as temperature of Y increases. Okay, likewise I'm writing in short form, so please write in full. So the resistance of Y will decrease. Okay, and the next thing you should talk about, before you talk about current, you must talk about the total effective resistance. Okay, the total effective resistance, because it's the sum of X and Y, so therefore will decrease. Next, using the I equals to V over R, where V is your EMF 9 volt and is constant, and your total effective resistance, we already said that is decreasing. So therefore, your current flowing through the circuit will increase. That means to say the current flowing through X equals to current flowing through Y, both will increase also because they are connected in series. So the next thing we need to talk about is using your Vx, because they're asking for the potential difference across X, which is your Ix times your Rx. And since Rx is constant, it won't change. Okay, it's a fixed resistor. As your current X, which we have concluded here already, that you will increase. Therefore, your V, potential difference across X, is directly proportional to the current flowing through X. Therefore, your Vx, potential difference across X, will increase. So that's how you answer this question, and it's rather straightforward. But I want to bring your attention to what if the question asks about V, the potential difference across your Y instead of your X. There's a difference, because just now the potential difference across X, this X is a fixed resistance, but this Y is a thermistor, the resistance changes. Now let's see what will be the problem if we use the same techniques. Now, most students will have the tendency using the same as what we did here. So they'll write Vy here equals to the current flowing through Y times the resistance of Y. But you will soon see the problem for this is because we already said that the current flowing through X and Y definitely will be higher because the main current increases, and because the temperature increases, the resistance of Y will decrease. So when one is increasing, the other one is decreasing, there's no way to convince the marker what will happen to the potential difference across your Y. So you can't use this method. Having said that, so even if I ask you the potential difference across your Y, you definitely have to go through all this explanation. You must make use of the potential difference across the fixed resistor. So after you have gotten this, you will say that both X and Y, they are connected in series. So the sum of potential difference across X and Y must be equals to the EMF, which is your 9 volt. Since already explained that your Vx, okay, will increase, therefore your Vy has to decrease. So that's how you explain using the concept of both of them connected in series. The sum of potential difference will be the EMF. So you will always make use of the fixed resistor to find what will happen to the potential difference, then use the fact that the sum of potential difference will add up to your EMF to conclude about your potential difference across your Y. So I hope if you come across this question, you'll be still able to know how to explain this. All right, thank you.